Okay, congratulations on making it through your first unit of advanced functions. Now we're moving on into the second unit, which is rates of change. We're actually going to be exploring rates of change throughout the entire semester, but we're going to pull out what essentially rates of change are now, so that when you see it for each of the functions we're going to explore throughout the course, maybe it makes a little bit more sense. First, we're going to start by exploring something called the average rate of change. And there's a definition up there on the top, but to put it in simple terms, it's basically how much is y changing while x is changing. And we can use that definition for multiple types of functions. And we'll look at some that are fairly familiar in this example, or in these two examples. Again, here's more to the definition. So it means over an interval from some x to some other x, the average rate of change is defined as this, which says the change in the function f of x divided by the change in x. What's the change in the function f of x? Well, it's some value at some other x value, subtract some other value. That sounds confusing. Let's try that again. We know that f of x is basically just y, right? It's function notation for y. So this is y2 minus y1 divided by x2 minus x1. And you might recognize this is basically just the slope equation. y2 minus y1 over x2 minus x1 is how we calculated slope of a line. And there's a reason it's so similar, is basically because it's the exact same thing. Finding the average rate of change is just finding the slope of a line. We're going to talk about what that line actually means and what that line is later in the lesson. But to find the average rate of change between 2 points on any function or any relation, we're just calculating the slope of a line between those 2 points. So let's look at a word example and a graph example to kind of illustrate that point. We'll start with the word example. It says a car leaves Thornhill at 3 p.m. and arrives in Niagara Falls at 5 p.m., traveling a total distance of 190 kilometers. Find the average velocity. This average velocity that we're being asked to find is an average rate of change. And if we, instead of writing average rate of change 1,000 times over, you can shorten it and just write AROC. AROC stands for average rate of change, and in this case the average velocity is just the average rate of change. Change in what? Well, change in distance. Where's our distance? Distance over some time. So the average velocity is just the average velocity over that time frame. And velocity is just distance over time, as we've seen before. So if we want to find the velocity, we'll call velocity v. That is just an AROC, an average rate of change. And specifically in this case, it's the change in d over the change in t, d being distance, t being time. Well, what is the change in distance? Well, in our question it says traveling a total distance of 190 kilometers. So that would mean if we started at a distance of 0 and ended up at a distance of 190, the change in distance would be 190 kilometers. So that 190 is the change in d. That's how far we traveled. What's the change in t? Well, if we left Thornhill at 3 p.m. and we arrived at 5 p.m., we could call 5 p.m. t2, time 2, and we could call 3 p.m. t1. The change in t would just be time 2 subtract time 1, which would be 5 minus 3, which is just 2. Let's get our units down here. That's 5 p.m. to 3 p.m., so that's hours, hours. So we have 190 kilometers in 2 hours. So on average, we've traveled 95 kilometers per hour. And that 95 kilometers per hour is an average rate of change. On average, how fast were we changing d, distance, with respect to time t? Example 2 will illustrate this idea on a graph. And to do that, we'll look at a familiar type of graph, a parabola. So first we actually have to graph our parabola, and we can do that by looking at the transformations on the parent function f of x equals x squared. We have two transformations. We have a value of 2, which is a vertical stretch by a factor of 2, and we have a shift up 3. That's actually not going to fit on our graph. I'm going to adjust that. We're not going to shift up 3. We are going to shift down. Let's go near the bottom. Let's shift down 8. So make that change on your handout. 2x squared minus 8 instead of positive 3, and that'll make the question a little bit better. So we're going to shift down 8 and stretch by a factor of 2, which means our vertex would be at 0, negative 8. And instead of doing the step pattern over 1, up 1, over 1, up 3, over 1, up 5, we're stretching by a factor of 2. So we're going to go over 1, up 2 to get our next point, over 1, up 5. Nope, that's not right. 4. And then, nope, that's not right either. Boy, I am struggling. Over 1, up 2, over 1, up 6, over 1, up 10. There we go. Now we're rolling. And we can do the same thing on the left side. Over 1, up 2, over 1, up 6, over 1, up 10. Instead of 1, 3, 5, we're 2, 6, 10. We've doubled the step pattern. So we have a good graph here. Let's connect it to get our nice parabola. And there's our graph for f of x. So what we want to do is we want to find the average rate of change from 1 to 3. And we want to use a sketch to support our solution. Is the rate of change positive or negative? Why? Okay, so we know that the average rate of change would be the change in our function f of x as it relates to the change in x, or the change in y divided by the change in x. So I'm going to write that down. Our average rate of change is the change in f of x divided by the change in x. Well, our x's are changing from 3 to 1, so that would be 3 minus 1, because this would be your x2, that would be your x1. x2 minus x1 is 3 minus 1. y2 minus y1, we're not going to call it y2 because in this case it would be the function at 3. So f at 3 minus f at 1. So what is f at 3? What is f at 1? Well, f at 1 is negative 6, and f at 3 is 10. And we can evaluate that using our function, or we can pull it off our graph. In this case, the points ended up directly on our graph, but if they didn't, we'd have to use our function to evaluate. So if we wanted f at 3, we do 2 times 3 squared minus 8. 3 squared is 9 times 2 is 18 minus 8 is 10. So the function at 3 is 10. So we've got 10 minus something. That something is the function at 1. That would be 2 times 1 squared minus 8. 1 squared is 1 times 2 is 2 minus 8 is negative 6. So it is 10 minus negative 6 divided by 3 minus 1, which is 2. 10 subtract negative 6 is 16, and 16 divided by 2 is 8. So our AROC from 1 to 3 is 8. 8 what? Well, there's no units here. We don't have units for f of x. We don't have units for x. So you could say it's units per unit if you don't have units, but if it is indeed unitless, you can stick with unitless. You don't have to include units. Okay, how can we show this on a graph? Well, the average rate of change can be seen on a graph. We talked about how it's just the slope of a line. So what line? Well, it's the line between x equal to 1 and x equal to 3, or the points here when x is 1 to the point here when x is 3. And I'm going to grab my trusty ruler. And I'm going to draw that line from 1 to 3. And basically what we did when we found the average rate of change is we just found the slope of this line. That line has a special name. And there's a blank there with secant next to it, so I bet you come to the conclusion that it's a secant line. And if you hadn't, well, I'm going to tell you right now, it's a secant line. So this line right here is a secant line. It's a line that connects 2 points on the graph of a relation. And we can say that the slope of a secant is the same as the change in y over the change in x, which is the same as the change in f of x over the change in x, which is exactly what we said an AROC is. So what's a secant? Well, it's a line connecting 2 points. The slope of a secant is an average rate of change, and that's what this whole lesson was about, average rate of change. Basically, this entire lesson, we're just looking for the slopes of lines. What lines? Secants. We're looking for the slopes of secants. When you hear average rate of change, slope of a secant. Thank you for watching, and I will see you in lesson 2.2, where we talk about instantaneous rate of change, or IROC. No, UROC. Thanks for listening.